All right, so this is the key to the log expressions, equation, and functions worksheet 1. In order to do these problems, these 10 problems, you need to remember this relationship. In one of the lessons, you saw that if you have b to the y equal x, so b to the exponent of y equal x, we saw that if we want to get y by itself, we want to get y by itself, so if we want to find out what y equals to, we defined this exponent as a logarithm. And so that logarithm, so we define that exponent, so the exponent y, as a log. And remember, if I'm going to get y by itself, then this right-hand side better have the two variables b and x. Okay, so this base here, so this base, remember this is called the base, so that base is the same thing as this base, so the base of a logarithm. So remember that's going to be that subscript right here. And then this x is the argument. So it turns out that if you have b to the y equal x, then that is equivalent to, and then is equivalent to y equals, and remember in terms of an exponential, so in terms of an exponential is equivalent to this equation that has a log in it. And so to go from an exponential to a logarithm, you have to remember that it's going to be the exponent is going to equal the log of the base. So the log base, whatever the base is, in this case is b, of what's on the right-hand side. All right, so it looks complicated, but it really is not. Once you practice a few, that relationship is going to be helpful. You're kind of remember that relationship. All right, so remember the exponent of an exponential you're going to rewrite as a logarithm. Okay, so let's look how this works. So in this problem here, you want to take this logarithm, so basically this right here, okay? So this right here, and you want to convert it to an exponential. That's what that says. So you want to write it into its equivalent exponential form, okay? So now look at the relationship. To go from a logarithm to its equivalent exponential form is easy. It's easy to see because look, you take the base, so it'll be b raised to this power equal the argument. So b to the y equals x. Okay? So over here, this is a b here. So you're going to say b to the 7 equal 8. So b to the 7th power equal 8. And there's your answer. So this log equation is equivalent to this exponential. We call this an exponential form. Okay? So b to the 7 equal 8. B to the y equal x. So that's what you see here. So let's look at the next one. So let's look at this one. So my base is b. I'm sorry, my base is 3. That's a 3 here. So you're going to say 3 to the 4 equal the argument. So 3 to the 4th power equal 81. And that's all you do. All right, and that's just using this relationship. So the relationship that this exponential is equivalent to this logarithm because we define the exponent to be a log. We define the exponent of an exponential to be a log. Now, in this particular case, you want to go the other way. So you want to go from an exponential to a logarithm, to its equivalent log form. All right, so what I need for you to do is this. So what I need for you to do is to recognize that the base that you're dealing with here is this 4. So you see 4 to the exponent, b to the y, okay? So you're going to say, remember, to write it in exponential, to write it in log form, you're going to take the exponent, okay, the exponent, and you're going to say that's going to equal the log of some expression. All right, so you're going to say the exponent is -3 equal the log of the base. Now remember, the base here is the same as the base here. So that'll be 4, and the only thing left is 1 divided by 64. All right, and that's going to be your answer. And it kind of makes sense because remember, going backwards, always think going backwards. 4 to the negative third, 4 to the negative third equals 1 over 64. All right. Quite a few students have trouble grasping this idea. It is not an easy thing to grasp, but as long as you see this relationship, then you could use this relationship and really get through these problems without any difficulty. And when you look at number 4, remember to go from an exponential to a logarithmic form, you have to make sure it looks like this. Right now it doesn't look like that. But we do remember, so I'm going to go ahead and rewrite this. So this is square root of 25 equal 5. And it makes sense, right? The square root of 25 is 5. But what we want to do is we want to rewrite this so that way it looks like something raised to a power. You have to remember that radical notation I can write as a rational expression, or rational exponent, excuse me. So that means that the square root of 25 I can write as 25 to the 1/2. And so 25 to the 1/2 equals 5. And so now this looks like number 3. So your exponent's 1/2, so you're going to say 1/2 equal log. So remember, the exponent is always a logarithm. So you're going to say the exponent, which is 1/2, is going to be the log of an expression. This base here is going to be this base here. So just make sure it looks like a subscript. Make sure it looks like a subscript. Okay? And then the only thing left is 5. And so 5 is going to be the argument. And that's how it looks. All right. So that was number 4. All right. Now number 5. So number 5, this is where you want to simplify, and the rest of these is simplify, evaluate without using a calculator. So number 5, you want to find out what the log of 49 base 7 is, or log base 7 of 49 is, without using a calculator. And so what you're going to do here is you're going to use this relationship. And so what I would do is I would think like this. I would say, all right, so I'm trying to find the log base 7 of 49. So I want to see what that equals to, right? So I could put this as an X, I could put this as a question mark, a box, or whatever notation you want to use here. And so now you see you have this log equation. So you have this idea here. So you want to change that to an exponential, and that's going to help you. So you're going to say 7 raised to what power equals 49. And then you can now guess at the answer. 7 to what power is 49? Well, 7 to the second power, right? 7 squared equals 49. So the answer is 2. And that's all that is. All right, so this right here equals 2. 7 squared. And it makes sense because 7 squared equals 49. Now over here, let's think about number 6. So this was number 5. Let's look at number 6. So number 6, we have log base 7 of 1 divided by 49. And let's say, you could say that equals X, that equals question mark, whatever you want to use. I'm just going to leave it as a box right now. And so changing this log equation to exponential, I have 7 to what power equals 1 divided by 49. Now, don't make that difficult. Let's think about what that is. So you remember that 49 is 7 squared, right? So this becomes 1 divided by 7 squared. And so what I have is I have 7 to what power equals 1 divided by 7 squared. But we also know from a previous course that 1 divided by 7 squared means the same thing as 7 to the negative second power. And so then what I have is 7 to what power equals 7 to the negative second. Well, look at what you have here. You have a left-hand side and a right-hand side where the bases are the same. So if the bases are the same, that means those exponents have to equal to each other. So that means that that what goes into this box right here, what goes in this box, has to be this exponent here. So therefore, the log base 7 of 1 divided by 49 is going to equal a negative 2. And so that goes there. Number 7, so let's look at number 7. So number 7, you have log base 2 of 32. Same thing, right? So just say equals x, whatever you want to, box, question mark, y, does not matter. But what you want to do is, once you write it like this, you want to change this to an exponential. So remember, you want to go from here to here. So you're going to say the base raised to this power equals the argument. So 2 to what power is 32? Well, 2 to the 5th power is 32, isn't it? So look, 2 raised to the 5th power is 32. So the answer is 5. So this right here must equal 5. All right, not that difficult. Very, very easy as long as you remember this relationship. And number 8, you have log base 5 of 5. All right, so you want to find out what that is. All right, do the same thing. Say equal. You're trying to find out what it equals to, right? So equal x, equal box, equal question mark, equal y, whatever you want to. Now we're going to change this log equation to an exponential. So your base is 5, so you're going to say 5 to what power equals the argument. Well, 5 to what powers is itself? Well, 5 to the 1st, right? So that equals 1. All right, now let's look at number 9. Now number 9, I'll do number 9 right here. Number 9, you have log of 10 to the 5th power. Log of 10 to the 5th power. Now, what you need to remember is that, see, you don't see a base there, right? Well, remember, that's understood to be 10. So this right here, if you want to write it, say that's log base 10 of 10 to the 5th. Okay? So remember that's a common logarithm. So a logarithm with base 10 is called a common logarithm. And so say equal, you're trying to find out what it equals to, right? So say equal box. And so now you're going to change this to an exponential. So your base is 10. So you're going to say 10 to this power equals the argument. Well, your argument is 10 to the 5th. Well, that kind of looks like number 6, this part here, right? So if you have an equation where the bases are the same, so the bases are equal to each other, that means the exponents have to be equal to each other. So here the bases are equal, so that means the exponents have to be equal. So 10 to what power is 10 to the 5th? Well, 10 to the 5th, right? So that equals 5. So the answer is 5 here. And then in number 10, you have the natural log of e to the 8th power. All right, now, remember, natural log, remember this is called the natural logarithm. So natural log has base e. So if you want to rewrite this as log base e. So this right here is this. So now you have natural log of e to the 8. It's the same thing as saying log base e of e to the 8. And then that's going to work out just like you did number 9. So if you say equal x or whatever, then you're going to change this to an exponential. Your base is e. So e to what power is the argument? And your argument is e to the 8th. Well, when you have an equation and the bases are the same, that means those exponents have to be equal to each other. So therefore, the log, or the natural log of e to the 8th, is just 8. That's all it is. All right. Now notice all I did to do these problems was to use this relationship. So that's a very important relationship. And that's it. All right. So hopefully you did fine with this assignment.